Good day, viewers all over the world. I welcome you to class today. Today we shall be looking at the last part of the series we started on coordinate geometry. We shall be looking at part 3 of coordinate geometry. Beloved, my name is Dr. Chris Esekaibe. I am the owner of this YouTube channel. The essence of the channel is to teach key topics in mathematics and statistics across the globe. The essence is to share knowledge in these areas. And for those of you who have subscribed to my channel, I want to thank you very much for subscribing to the channel. The essence of the channel, as I have been saying since the channel began in January, is to share knowledge in key areas in mathematics and statistics. For those of you who have been helping in sharing knowledge, sharing my videos in your social media platforms, I'm very grateful. Thank you very much. And for those of you who are yet to subscribe, you have been watching the videos and you are yet to subscribe, please subscribe. Be part of those promoting the channel. Be part of those sharing knowledge across the globe. Share it among your friends. Share it in your social media platforms. And as you do, God will bless you in Jesus' name. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor degree in statistics. I'm a specialist in numerical analysis, data analysis and modeling, scientific computing, and statistical analysis. For those of you who have AI firms, or you are working with AI firms in training AI models in mathematics so that the models can understand mathematical algorithms, I've been privileged to work with 2 AI firms in the United States of America, and I was part of those training the models. What we do, we create prompts. I create prompts to break the models, to stomp the models, and also create rubrics and golden responses or chain of thoughts to train the models. And that has been very impactful, and the 2 organizations in the United States were very grateful for my impact. And also, if you are a research institute and you do a lot of statistical research or mathematical research, you can contact me to be part of your team of mathematicians and statisticians. And if you are a research student, a postgraduate student in numerical analysis or even statistical analysis, you are doing a postgraduate studies in statistics or mathematics, and your area of specialization is numerical analysis, you can consult me. Somebody consulted me from Malawi, another one from Uganda, and so on and so forth. My contacts are displayed on the board. My contact, the first contact is +234 80 330 This first contact is for call and for WhatsApp. The second contact is only for call, +234 70 66297535. The second contact is only for call, and my email is also displayed, chrisdavids2015@gmail.com. I will be looking forward to hearing from you. We shall be looking at coordinate geometry part 3. For those of you who have watched part 1 and part 2 of coordinate geometry posted in my YouTube channel, I want to congratulate you. This is the crowning part of the coordinate geometry for beginners, for those that are doing a first course in coordinate geometry, whether you are an engineering student or a science student or a student in architecture or physical sciences, or whichever part of the sciences you are offering a first course in coordinate geometry. This will definitely be of great help to you. So permit me to claim my contacts so that we can go directly into the business of the day. We have a whole lot to do today. So please watch the video patiently from the beginning to the end so that you have a better understanding of what the concluding part of coordinate geometry is. And today we are looking at the equation of a circle, the equation of the parabola, the equation of an ellipse, and the equation of a hyperbola. So we shall be starting with the circle today. Now, this is one key part in coordinate geometry that most authors have not been able to explain very well. First of all, we start by defining what a circle is. A circle is the locus, or you can say it's a locus. A circle is a locus of points equidistant from a fixed point called the center of a circle. Let me give an example. If I have this graph, for instance, I want to explain this. Of course, definitely, you know, this is our x-axis and this is our y-axis, and I have a circle here, and this is the center of the circle. From the center of the circle, you draw a line to any part. This part is called the circumference of the circle. When you draw any line from the center of the circle to any part of the circumference, that line is called the radius. So if I have this and it meets at a point of the circumference, let's call this point P, and of course every point has a coordinate. Every point has two coordinates, the x coordinate and the y coordinate. The x coordinate is called the abscissa, while the x coordinate is called the abscissa, while the y coordinate is called the ordinate. Now this is the center of the circle, and we normally call this center of the circle O. And O, which is also a point, can also have a coordinate A and B, the x coordinate A and the y coordinate B. Now we can decide to form a triangle here. This is now giving us a right angled triangle. So you can see that we can now trace this point at which is the center of the circle down to the x-axis, and of course this will be at point A. Then of course you point it to the y-axis, and of course this will be B, because the center O has two coordinates A and B. A is the x coordinate, B is the y coordinate. Then at this point P, that is, there is a straight line from the center of the circle to a point on the circumference, and that point is P. So P also has its own coordinate, x coordinate and y coordinate. So we can trace this from point P to the y-axis. We can call this one y, that is the y coordinate. We can also trace this down to the x-axis, and we call this value x. So you can see how we are able to do this. So you need to know that any line that divides the circle equally into two equal parts is called the diameter. So the diameter is equal to 2 radii. Is equal to 2 radii. That's what the diameter is. Now, any other line that divides, that cuts across the circle, that is not cutting across it from the center, is called a chord. So you should know the difference between the chord and the diameter. So when you multiply the radius by 2, you have a diameter. The diameter is a line that divides the circle into two equal parts. So now you can see that by Pythagoras theorem, or by the distance formula that we considered in the first part of coordinate geometry, how to calculate the formula for calculating the line joining 2 points. Now look at the center of the circle, then look at the point on the circumference. So now, and you can see this is our radius. From the center to any part of the circumference is the radius. Now you can see that we have been able to form a right angled triangle, and by Pythagoras theorem, of course, you will know that. No, you will now know that. Look at this particular point here. This particular point here will now be that is from this line. This line from here to here will now be x minus a. Then this particular line from here to here is also equal to the line from here to here. So and this one the difference is y minus b. So you can call this y minus b. It is allowed. So now this place will be called your y minus b, while this particular place will be called your x minus a. That is what it is. So now you can see we have the three sides of the triangle. Then we can now come, that means by Pythagoras theorem, our r squared, which is the same thing as the distance formula, and the formula for getting the distance between 2 points will now be equal to x minus a squared, which is this part, then plus your y minus b squared. So this will now give us what we call the equation of the circle. So you can see how it has been easily gotten. So you can see that the coordinates of the point P are x and y, while the coordinates of the center O, we normally call the center O, is a comma b. So using the distance formula, we have been able to get the equation of the circle. Now, if I have another opportunity, say I have something like this. This is my y-axis, this is my x-axis, and I have a circle here. Now you can see this particular point here now is now where, if the origin is now the center of the circle, the origin of the graph here is now the center of the circle. And of course, from this center here, you draw a line here, then you get it, you form a right angle triangle. Then of course, from this center, we are having our coordinate to be A and B. So now in the situation whereby the center of the circle O is having the coordinates to be 0 and 0. That simply means that your A will be 0 and your B will be 0. If you have this kind of situation where the center is at the origin of the graph, then of course your A will be 0, your A will be equal to 0, and your B will be equal to 0. This simply means that the area of the circle will be the radius square will be equal to x squared, because x minus 0 will be x squared, then plus y minus 0 will be y squared. So this will now be the equation of the circle. That will now be the equation of the circle in a situation whereby the center of the circle is at the origin of the graph. That means A, the coordinates of the center of the circle, the point, or you can call it the center of the circle, will now be 0 and 0. That means A will be equal to 0 and B will be equal to 0. So that is the equation of the circle with center at the origin and the radius is arrow. So our arrow is equal to the radius. So when the center of the circle is at the origin of the graph, then of course you have it to be the radius square equals s squared plus y squared. So of course P is any point at the circumference of the circle. So you can see this is how we have been able to get the area of the circle. So permit me now to go. You can see that like from definition, a circle is a locus of points equidistant from a fixed point called the center. So this is the fixed point. Any point you draw to the circumference, this one is also arrow. You draw another one to here is arrow. You draw another one to here is arrow. So any line you draw from the center of the circle to the circumference, that particular line is called the radius. So permit me to clean this part of the board as we take an example. Please wait patiently to the end. We are looking at 4 different shapes. We are looking at the circle, we are looking at the parabola, we are looking at the hyperbola, and we are also looking at the ellipse. So it is good for us to wait patiently. Now let us consider an example. Let's call this example 1. Example 1 says, find the equation of the circle with center. Find the equation of the circle with center minus 5, comma 3, and radius arrow equals 8. So now from the solution, you know, the equation of the circle is easy to get if normally you know that the center is normally written as O and it has two coordinates A and B. So if that is the center, that means that this implies that our A is equal to minus 5 and our B is equal to 3. That is what it means. So the equation of the circle is r squared equals x minus a all squared plus y minus b all squared. And what is our arrow? Our arrow, of course, we are told that our arrow is equal to 8. That is the radius. So we have our 8 squared is equal to, of course, x minus, what is our a? Our a is minus 5. You put it here, minus 5. You cover the bracket, then you square, then plus y minus, what is our b? Our b is 3, then you square. All you just need to do is to open the bracket and collect the like terms, and you arrange. So you are going to have this the equation of the circle to be x squared plus y squared plus 10x minus 6y minus 39, and this will be equal to 0. So always make the right hand side to be 0. So you can see that we have been able to calculate the equation of the circle. Now let's take another example. Let's take this one as example 2. Example 2 says, find the center and the radius of a circle. Find the center and radius of a circle whose equation is x squared plus y squared, x squared plus y squared minus 8x plus 4y equals 12. So now let's take the solution quickly. Now if you look at this is not the main standard of the equation of a circle. Now what we need to do, the equation of the circle is written as r squared equals x minus a all squared plus y minus b all squared. So we need to put this particular equation in the form so that we'll be able to know what our arrow is and what our center, that is value for a and value for b, what they are. So now what we are going to do, we are going to divide. We are going to use the method of completing the square. We are using the method of completing the square. If you come here now, what is the coefficient for x? Coefficient of x for x is minus 8. When you divide it by 2, you have minus 4. Then what is the coefficient for y? Coefficient for y is 4. Then you divide it by 2. Then you are going to have 2. So this will now be for x. So meaning that this particular, we can now put this particular equation into this format. So meaning we are going to have, from this we are going to have x minus 4 squared, because that is the method of completing the square. You can see the coefficient of x here is minus 8, so we divided it by 2. That is how, if you are conversant with the method of completing the square, then plus, then for y, the coefficient of y is plus 4, we divided by 2. So you now say y, because this one is plus 2, you put plus 2 all squared. Now, you need to understand that this particular, when you open this bracket, when you open this particular bracket, you are going to have s squared, you are going to have x squared plus minus 8x plus 16. Then you put this plus sign here. When you open this, you are going to have y squared plus 4y plus 4. That's what you are going to have. Then of course, when you have this, now look at this. Here we have, that means we are coming here to subtract this minus 16. Now is an intruder here. You see it. Then this plus 4 is, this plus 16 is an intruder here. It's not part of this main equation. So what we normally do now, you are now coming to subtract. You are now going to turn this to minus 16, and you are coming to turn this to minus 4, because they are not part of it. Then of course, this our minus 8x is here, plus 4y is here. Then having that, of course, at the end of the day, you now have that to be, of course, okay, let's put the plus and plus. Then definitely you come here and put minus 16, then you put your minus 4, then of course is equal to 12. So you can see that that will now definitely remove this part. It will now make us to have, yeah, that means here we are going to have minus 16, then here we are going to have minus 4, then is equal to 12. So this is used as explanation to that particular part. So you come here. So this is using the method of completing the square. This is what you now finally arrive at. Because when you open this bracket, don't be confused, it's simple to understand. If you open this bracket, there will be a plus 16. And that means you have to subtract 16 from this to make it x squared minus 8 only. Then if you open this bracket, you are going to have y squared plus 4y plus 4. Of course, you need to minus 4 so that you can have it as y squared plus 4y. Then of course the right hand side remains. So that is what we do using the method of completing the square. So remember, you shift the order to the right hand side, then you come here, you are going to have you take minus 16 to the other side, becomes plus 16, take minus 4 to the other side, that is minus, all this minus 20 goes to the other side, becomes plus 20. So 20 plus 30 plus 12 becomes 32, is now equal to x minus 4 all squared plus y plus 2 all squared. So looking at this, it is comparing it with the equation of the circle. Look at it here now. This simply means that from here, our r squared is equal to 32. So this implies that our r is equal to square root of 32. That is the radius. You can see by comparison, r squared is here on the left hand side, 32 here is here on the left hand side. Then if you compare this and this, you will see that a is equal to 4 without much, so by comparison, our a will be equal to 4. Look at it here, this is x minus a squared, x minus 4 squared. So by comparison, our a equals to 4. Then you come here, y minus b, this is y plus b, that means minus b. This will now imply that minus b will be equal to plus 2. So this implies that b is equal to minus 2. So if you now come here, from this particular problem, our center will now be, which is 0, O is our center, and it's having coordinates A and B, will now be equal to, the center will now be, what is our A? Our A is 4 and our B is minus 2. Then our radius is root 32. So that is how that particular problem is solved. So beloved, we have looked at the circle. Now let us go and take another problem and look at the parabola. Let's clean this part of the board. Then we'll take a look at the parabola. Parabola, we are taking the 4 of them. We are done with the circle. If you have any question, you can drop the question in the comment section and the question will be attended to. It will be attended to. Just drop any question you have on the comment section and it will be attended to. So now we are looking at the parabola. The parabola. We are looking at the parabola. A parabola is the locus of all points in the plane which are equidistant from a fixed point F and fixed line L. So there is a fixed point F, fixed point F, and a fixed line L. So that is what a parabola is. Now I come again with the definition. A parabola is the locus of all points in the plane which are equidistant from a fixed point F and a fixed line L. The fixed point F is called the focus, while the fixed line L is called the directrix. So this is called the focus and this is called the directrix. So the fixed line is called the directrix, while the fixed point F is called the focus. Now the equation of a parabola is either of the form, now the equation of a parabola, is either you have it of the form, it's either you have it as x squared equals 4ay. When you have that as the equation of the parabola, then the focus F will be at, that means the focus F will now be at, a, 0, or if you have it as y squared is equal to 4a, if you have 4ax, if you have it as this, if you are having it as x squared equals 4ay, then the focus will be this. Then of course the directrix, which is the fixed line, the directrice will be equal to x equal to a. That is for that. Then if you have this one here, you can see that this is x squared. That is why a is the x coordinate. But if you are having it as y squared equals to 4ax, then the focus will be at 0, a, because here you are having it as y, so the focus will now be at the y coordinate. Then the directrix will be y equals to a. So it's as simple as that. It is as simple as that. So if you have this, it can either be x squared equals 4ay, that means the focus will now be at a, 0, or if you have it as y squared equals 4ax, the focus will be at 0, a, because it's now at the y, a is now the value of the y coordinate. Now, doing this, when the parabola is obtained and the coordinate of the focus, then the equation of the directrices are given. The equation of the parabola can also be obtained when the coordinates of the focus and the equation of the directrix are given. Then we have the coordinate of the focus to be, let the coordinate of the focus be x1, y1. If the coordinate of the focus is or the coordinates of the focus are x1, y1, and the direction of the directrix, this is for f, and the directrix is given as ax plus by plus c is equal to 0. That is the line. If you have that, and we have xy to be the coordinate of any point on the curve, xy to be the coordinate of any point on the curve, then we will now have the general equation of the parabola, the general equation of the parabola to be, we will now have the general equation of the parabola to be ax plus by plus c all squared equals a squared plus b squared, then bracket open, x minus x1 all squared plus y minus y1 all squared, then you cover the bracket. So you know that this is the directrix. The directrix is a line, it's a fixed line, and is given by that equation ax plus by plus c equals 0. Then the focus has two coordinates, x1 and y1. Then of course this point xy is any point, that one is any point that is defined on the curve. So this will now be the general equation of the parabola. Now let us take an example and see how we can, let's go ahead and take an example. So permit me to clean this part of the board. Of course, the parabola is as simple. All you just need is to know the fixed point, the focus, and the fixed line, the directrix. And when you have it, you have the equation of the direction of the directrix, which is given as ax plus by plus c, and also you also know the coordinates of the fixed point, which is the focus, to be x1, y1, and you have another coordinate which is on the curve to be xy. Then you have the general equation of the parabola. Now let us take an example. Let's call this example 1. For this example, we say find the focus and directrix of the parabola. Find the focus and directrix of the parabola. Roman figure 1, you have y squared is equal to 6x. Then Roman figure 2, you have x squared is equal to minus 5y. Now you can see, let us start with the solution for Roman figure 1. Now you can see that this is y squared equals 6x. Now we are told to find the focus. Of course, the focus F, definitely it will have coordinates of x and y. We are also to look for the directrix. You must remember that from the definition we gave for the parabola, we have our y squared equals 4ax. That is what we have. And if we have that, that means that the focus will be at the point, 0, a, because you can see it's y that is here. So the a value will be as the y coordinate. So now comparing this and this, the Roman figure 1 says y squared is equal to 6x. Now look at your y squared, look at your y squared, look at your x, 4a. That means by implication, our 4a is equal to 6. By implication. So this implies that our a is equal to 6 all over 4. So our a will be 6 all over 4, and which will be equal to 3 all over 2. And of course, this is greater than 0. So if that is greater than 0, then the focus F is on the y-axis, and the coordinates of the focus F is on the y-axis, its coordinate as given by this will be 0, what is our a? Our a is 3 all over 2. That is what you have there. So that will be the coordinate. Now, remember, the directrix is a line. Since the focus is on the y-axis, we know that the directrix on the line y equals to a, because that is what the question is. The focus is on the y-axis. So this simply means that the directrix, since the focus is on the y-axis, the directrix will now be y equals 3 all over 2. That is y equals a, and our a is 3 all over 2. So the first question has been solved. So now let's go to the Roman figure 2 of the problem. Let's go to Roman figure 2. Then for Roman figure 2, remember, this one here, is our x squared. That means if the focus is on the x-axis, our x squared is equal to minus 5y. Then we also know that our x squared is equal to 4ax. Then the focus will now be, the coordinate of the focus will now be a, 0, because it's on the focus is on the x-axis. F, which is the focus, is on the x-axis. So we now have it, that's the coordinate here. A will now be the coordinate of x. So now, by comparison, look at x squared is equal to minus 5y, x squared is equal. So from here, our 4a will be equal to minus 5. Minus is 4ay, not 4ax. So look at it now, y is here, y is here. So minus 5 will be equal to 4a. So by implication, our a will be equal to minus 5 all over 4. That is what our a will be. So the coordinate of the focus of the focus will now be minus 5 over 4, 0. You see it? Because it's on the x axis. The focus is on the x axis. That's why you're having x squared is equal to minus 5y. So, and this is the relevant equation of the parabola. Then, of course, the directrix x will be equal to a. X will be equal to, because it is on the x axis. So this implies that our x will be equal to minus 5 all over 4. That is what the directrix will now be, which is the line, the fixed line. The fixed line will now be minus 5 over 4, and of course that is less than 0. So you know what that means. If you are drawing it in the graph, if it is less than 0, it will go to the negative part of the x-axis. But for the first one is greater than 0, of course it will go to the positive part of the y-axis. So y, the fixed line, which is the directrix for the first problem, is y equals to 3 over 2, which is the value for a, and for a is minus 5 all over 4. So I believe you are getting along with this. Now let me still take one more example on parabola, so that we can a situation where we will be able to apply the general equation of the parabola. Where we'll be able to apply the general equation of the parabola. Please, if you have any question, you can drop the question on the comment section. For those of you who have not subscribed to my channel, please do so, and as you do, God will bless you richly. Now let us take another example. Let's call this example 2. Example 2. The example 2 says that find the equation of a parabola. Find the equation of a parabola find the equation of a parabola whose focus is the point, whose focus is the point minus 1, 1, whose focus is the point minus 1, 1, and the directrix is the line, and the directrix is the line. The directrix is the line x plus y plus 1 equals to 0. So that is the question. Now remember, now let's go straight to the solution. We gave the general equation of the parabola to be ax plus by plus c all squared equals a squared plus b squared, then another bracket open, x minus x1 all squared plus y minus y1 all squared, then you close the bigger bracket. Remember, this is the directrix ax plus by plus c as given by definition. Then x1, y1, they are the coordinates of the focus. The focus is the fixed point, and of course x and y are any point on the curve. So now that we have this, you can see that from what we have, if the focus f is having x1, y1 as coordinates, that means and is equal to minus 1, 1. So this implies that our x1 is equal to minus 1 and our y1 is equal to 1. So that is what it means. And look at our directrix is given as the line a x plus by plus c is given as the formula, and from the question is given as x plus y plus 1 plus 1. This is what it was given in the problem. So this implies that what's the coefficient of x here? A. What's the coefficient of x here? 1. So our a is equal to 1. What's the coefficient of b of y here? Is b. What's the coefficient of y? Is 1. That means our b is equal to 1, and of course c will be equal to 1. So that is how it goes. You can see that we have been able to get all the necessary parameters that are needed for this particular exercise. So carrying this out, it simply means that from here, what is our directrix? Look at our directrix here. So putting this into that, so the equation of the parabola is, now look at it, this is the directrix here. And what is our directrix? Our directrix is x plus y plus 1. Then of course there is a square. That will be equal to, what is our a? Our a is 1, so 1 square will be 1. What is our b? Our b is 1. B square, that is 1 square will be 1. 1 plus 1 will be 2. So you can just put the 2 into bracket open. What is our x? Of course we have our x minus, what is our x1? Our x1 is minus 1. Minus x minus minus 1 will be x plus 1. Then of course you square it. Then plus our y. What is our y1? Our y1 is 1. So it will be y minus 1. Of course you square it. You get the bigger bracket. Now carrying this out, simplifying this to its simple form, you are going to have the general equation of the parabola. When you simplify this particular equation here, you are going to have x minus y all squared plus 2x minus 6y plus 3 is equal to 0. So after simplifying this, you open this bracket, multiply everything by 2, open this bracket, you simplify it to have this. If you're having any challenge doing that, then you let me know. So this is how far we can go concerning the parabola. Now we want to take a look at the ellipse. The ellipse. Permit me to claim the parabola. Now I believe you have gotten a proper understanding of what the equation of a parabola is. Now let's take the third one, which is the ellipse. Now the ellipse can be defined as the locus of points in a plane in such a way that the sum of its distance from 2 points, the 2 points are f1 and f2, is constant. The sum of its distance from 2 points, the 2 points are f1 and f2, is constant. So the points f1 and f2 are called foci. So f1 and f2 are called foci. Of course, foci is the plural of focus. So the ellipse has 2 foci, 2 fixed points, and the sum of it is constant. Then you must understand that the ellipse moves in such a way that its distance from a fixed point, the focus, bears a constant ratio. That constant ratio is called the eccentricity. There's a constant ratio. called the eccentricity. And that eccentricity is E. For the ellipse, E takes value between 0 and 1. E takes value between 0 and 1. So E is greater than 0, but E is also less than 1. That is what E is, which is the eccentricity. Now the equation of the ellipse is given as the equation of the ellipse is given as we have x squared all over a squared minus y squared all over b squared is equal to 1. Then for this case, our a is greater than b. So you can also have it on the other side, where you can have you can have your x squared all over b squared minus y squared all over a squared. And for this particular case, your a is less than b, and when your a is less than b, it simply means that here we are going to have our b squared is equal to a squared minus c squared. That is what we have. So these are the two that we have, the two equations of the ellipse. It depends if a is greater than b or a is less than b. You know the one that you choose. And it is good to understand that when you have x squared over a squared, this other, it has two parts. The ellipse has two parts, the major part and the minor part. The part with the negative, like for this particular equation here, this part is the minor part because it has the negative coefficient, while this part is the major part. Then for this other one, this part is the minor part because it has the negative sign coefficient, while this part is the major part. So you should understand when it has the major part and the minor part. So now we want to take an example and see how we can resolve this. Let's take an example. So an example, for instance, this example says obtain the length of the major and minor axis and eccentricity of. It said obtain the length of the major and minor axis and eccentricity of x squared all over 27 plus this plus sign, x squared over 27 plus y squared all over 10 is equal to 1. So you must understand this. You must understand this. So it is good for you to know that we are using this part here. Now compare this with this. Comparing with this, you will understand that from here it is very easy. Look at it here. Our a squared is equal to 27. So this implies that our a is equal to root 27. Then of course, our b square is equal to 10. This implies that our b is equal to root 10. That is what you have there. So our b will be root 10. So remember also from here that our c square from this particular equation here, our c square will be equal to a square minus b square. So our a square minus b square, that will not be, what is our a square is 27 minus our b square is 10, and that is 17. So this implies that our c will be root 17. It is as simple as that. So by definition, our eccentricity E is defined as, by definition of an ellipse, our eccentricity E is defined as C over A. What is our C? Our C is root 17. What is our A? Our A is root 27. Root 27. And you can see this answer is less than 1 by the definition of eccentricity. The value of the eccentricity is greater than 0, but it is less than 1. So it is root. If you find the value of root 17 over root 27, you will see that the answer is less than 1. So our E, the formula for E is C all over A, and we have been able to get that. So the foci are, to get the foci, of course we said the foci are 2. To get the foci is very easy. You have it as, the foci will now be the point minus c, 0 and plus c, 0. That will now be the foci. So along the x-axis, because the major part of it here is the x-axis, since the x-axis is the major axis there. So getting our foci, we are going to have, what's the value for c? Our c is root 17. So we are going to have minus root 17, 0 and root 17, 0 as our foci. Minus c minus root 17 is 0. C, our c is root 17. So we need to have that. That is what we have as our foci. So at this point, you will see that it is very easy to get this value. Now, let us take another example of an ellipse, a problem that will be solved on ellipse. I hope you are following the class. Please, if you have not subscribed to my channel and you are a first viewer, please subscribe to my channel. Click on the notification button, share my videos in your social media platform, and as you do, God will bless you on every side. Thank you very much. Now let us take another example of the ellipse. We can call this example 2. Now the question says find the foci and the eccentricity of the ellipse. Find the foci and eccentricity of the ellipse. The foci and eccentricity of the ellipse, we have it as 9x squared plus 25 plus 25 y squared equals 225. Now let us take the solution. The solution is simple. Now what we need to do, divide both sides of this given equation by 225. So divide both sides by 225. So you are coming here, you are going to have 9x squared over 225 plus 25y squared over 225 is equal to 225 over 1 over 225 over 225. So this implies that we are going to have x squared. We are going to have x squared over 25. So 9, of course, divided by 225 is 25, then plus 25 divided by 225 will be 9, then plus y squared all over 9 is equal to 225 over 225 equals to 1. So we have gotten the equation of the ellipse. You can see that again, the major part there is the x squared over 25. So from here, it will be very easy. Since you can see here now that how do you know the major part and the minor part? Look at the denominator of x squared is 25. So since 25 is greater than 9, since 25 is greater than 9, then the major axis is along the x-axis. X-axis is the major axis. That's what it means. So there will always be a minor axis and the major axis. How do you know the minor axis, the one that is lesser? The denominator of x squared is 25, the denominator of y squared is 9, and 25 is greater than. So and 25 is the denominator of x squared. That means our x axis is the major axis, while the y axis will be the minor axis. So now it is time for us to get the values for a, b, and c. So now from here you can see that here our a squared is equal to 25. So this implies that our a is equal to 5. We take the square root of 25. Then here now our b squared is equal to 9. This implies that our b is equal to square root of 9, 3. And remember, our c squared is equal to a squared minus b squared. And that is equal to, what is our a squared? 25 minus, what is our b squared? 9, and that is equal to 16. So our c will be equal to square root of 16, and that will be equal to 4. So you can see we have been able to get that. So it's as simple as that. Now remember our eccentricity. The question says we should find the foci. Remember the ellipse has two points, two fixed points that are called the foci. Now the eccentricity is given by the formula eccentricity is given by the formula eccentricity is E is given by the formula C all over A. Is given by the formula C all over A. What is our C? Our C is 4. What is our A? Our A is 5. So this implies that our E is equal to 4 over 5, and of course it is less than 1. Remember, we are told that 0 less than E less than 1. The eccentricity must fall within that particular bracket. It must be less than 1, and it must be greater than 0. So now, remember our foci are the points minus c, 0 and c, 0. Now what is our c? Our c is 4, so we are going to have minus 4, 0 because it's at the x-axis. Are you getting it now? The the major part is the x-axis, because 25 is greater than 9. Then of course the second part of the foci will be 4, 0. Our C is 4. So this is the solution to that particular problem. So I believe we have gotten that. Now permit me to go to the last part of today's topic, which is the hyperbola. I believe you have looked at the ellipse. We solved 2 problems and it has been explained. You will see the difference between the ellipse and the hyperbola. For the ellipse, the eccentricity is greater than 0 but less than 1. But for the hyperbola, the eccentricity is strictly greater than 1. So let us look at the hyperbola and call it a day for this particular topic, coordinate geometry. We started this series. In our last 2 videos, we considered coordinate geometry part 1. We also considered coordinate geometry part 2. And today we are looking at coordinate geometry part 3. Now we want to look at the hyperbola. The hyperbola. Listen to the definition of the hyperbola. A hyperbola is a locus, or is the locus of a point which moves in such that its distance from a fixed point, focus, that is the fixed point, it has a fixed point which is a focus, you can call it F, and it bears a finite constant ratio called the eccentricity. So it has a focus F, and eccentricity. And this eccentricity is denoted as E, and you must know that E is strictly greater than 1 for the hyperbola, unlike the ellipse. So it bears a constant ratio E, which is the eccentricity, and that is greater than 1 to its distance from a fixed line. So it also has a fixed line. It has a fixed line called the directrix. It has a fixed line called the directrix. So the eccentricity, okay, let's start with the equation. The equation of a hyperbola is given as the equation of a hyperbola. Equation is given as you have x squared over a squared minus y squared over b squared, and that is equal to 1. That is for the this simply means that with this, the eccentricity is still given as c all over a. The eccentricity is given as c over a. Then the directrices are the lines. The directrices are the lines. The directrices are the lines. X equals the directrices. Directrices are the lines. We have x equals minus a over c, and x equals a over c. So it has 2 directrices. It has 2 directrices. So this is the first equation. You can also take, you can see that the major part here is the x-axis. The y-axis is having a negative coefficient. So the one with the negative coefficient is the minor axis, while the one with the positive part is called the major axis. Also, we can also have the hyperbola, or we can have it as x squared. We can have it as y squared all over a squared minus x squared all over b squared is equal to 1. And of course, here the eccentricity remains the eccentricity remains C all over A. That is the eccentricity. E equals C all over A. Then you can see here now the x-axis is the minor part because it's having the negative coefficient, while the y-axis that is having the positive coefficient will now be the major axis. So you need to understand that. Then of course the directrices for this particular one, the directrices will now be, directrices are the lines. The directrices will now be the lines y equals A over C minus A over C, and y equals A over C minus A over C. So because here you can see x, the x-axis is the major axis, that's why you are having the lines to the x equal to minus A over C and x equal to A over C. Here now the y-axis is the major axis because it has the positive part, that's why you are having the directrices to be minus A over C and plus A over C. So you should understand that the length of the chord of the hyperbola passing through the focus and perpendicular to the transverse axis is given by 2. So the length of the chord will be equal to 2b squared all over, it will be 2b squared all over A. So you need to note that that is the length of the chord that is passing through the focus and perpendicular to the transverse axis. So that is 2b squared over A. So you should note that the equation of the tangent at any point xy is the curve. So this simply means that that particular point x1 y1 is also the chord that is given. So now we want to take an example and see how we can solve the problem. Now example, the example says find the focus and eccentricity of the hyperbola. Find the focus and eccentricity of the hyperbola. The focus and eccentricity of the hyperbola. Of course, we have two of them. The first one is A. A is x squared over 16 minus y squared over 9 is equal to 1. So this is the first one. So from this particular problem, you should understand that from here, for the hyperbola, we have our c squared equals a squared plus b squared. So our c squared is equal to a squared plus b squared for the hyperbola. It is different from the ellipse. It is different from the ellipse. If it were to be the ellipse you will have that to be b squared equals a squared minus c squared. So here you have your c squared to be equal to your a squared plus your b squared. Now let's go ahead and see. So from this particular problem, look, considering this, so the major part is the x-axis, the part that has the positive coefficient. So here the minor part will be your y-axis. So now from here, comparing this with this, it means that our a squared is equal to 16. This implies that our a is equal to 4. Then from here, our b squared is equal to 9. This implies that our b is equal to 3. So using that particular equation, you see that from here, our c squared is equal to a squared plus b squared, and is equal to a squared is 16 plus b squared is 9, and that is 25. This implies that our c is equal to root 25, and that is equal to 5. Our c will be equal to 5. Now remember, our eccentricity E is what? C over A. What is our C? Our C is 5 and our A is 4, and that is 1.25. And we are told that the eccentricity is greater than 1. You see it? 1.25 is greater than 1 for the hyperbola. Then the foci are the points. The foci are very simple to get. The foci are minus a, 0 and a, 0. So what is our a? Our a is 4, so you have minus 4, 0. And what is our a again? Is 4, 0. Why are we having the x coordinate? Because the x is the major axis. So that's why we are having it. If it is y that is the major axis, you are going to have it as 0, minus a and 0, a. Because here y is the major axis, but it's not going to be this because x is the major axis for this particular problem, so we do it like that. So now let us take another example. Permit me to clean this part so that you will understand it. By the time we solve another example, maybe this example is having x, is having the y-axis as the major axis. This particular problem we just solved, the major axis is the x-axis. The major axis is the x-axis because you can see it's having the positive, the coefficient of x here, s is the positive part, y is the negative part. Now let us take the second example. The second example says, find the focus and eccentricity of the parabola. This one you have y squared all over 25 minus x squared all over 16 is equal to 1. So you can see this particular problem is different from this particular problem. For this particular problem, you can see the positive side is the y squared. So the y-axis is the major axis, while the x-axis is having a negative value. That will now be the minor axis. So now, when you now come here, we now want to get the positive part is y squared over 25. So making the x-axis the foci to concentrate on the y-axis. So the y-axis is y squared over 25. That is the major part, the positive part. So from here now, we can get from here, since our a squared is 25, this implies that our a is equal to 5. Then from here, our b squared is equal to 16. This implies that our b is equal to 4. And remember, our c squared is a squared plus b squared. So our c squared is equal to a squared plus b squared. So c squared is equal to 25 plus 16 is equal to 41. So our c will be square root of 41. It's as simple as that. So our eccentricity E is c over a, and that is equal to, what is our c? Our root 41 all over a. What is our a? Our a is 5. So, and of course, this will definitely be greater than 1. So for the hyperbola, the eccentricity is greater than 1. The eccentricity is greater than 1. Then for us to get the foci, of course, since it is on the y-axis, the foci are on the y-axis. So the foci are on the y-axis. So we are now going to have it as we are now going to have the foci as, from here we are going to have it as 0, minus c and 0, c, because now we are now making use of c, which is, so we are now going to have 0, minus root 41 and 0, root 41. So you can also be told to get the length of the chord. The length of the chord is simple. Of course, if you want to also get the directrices, the directrices are y equals a over c, y equals a over c, y equals to minus a over c. So the directrices will be y equals, what is a? Our a is 5 all over c is root 41, y is equals to minus 5 all over root 41. That is what you have there. Those are the directrices. Then you can also get the length of the chord. You can calculate as many things as possible. So the length of the chord is 2b squared all over a. So length of the chord, you can call it L, so that will now be 2 into what is our b square. Our b square is 16 all over a. Our a is 5. So that will be 32 all over 5. You can see this is as simple as ABCD. So we have been able to come to the end of this particular topic, coordinate geometry, part 3. We have reached the end of today's class. So beloved, I hope you have been able to wait patiently to watch this video to the end. If you have any question, please, you are permitted to put the questions on the comment section, and I can assure you that the questions will be treated accordingly. The answers will also be given to every question that is asked. Thank you very much for watching the video to the end. For those of you who have subscribed, I really appreciate your time and your effort. And for those of you who are first viewer, you're watching this video for the first time and you have not subscribed, please subscribe to promote the channel. The essence of the YouTube channel is to share videos or to share knowledge across the globe. And if you do that, God will bless you. Thank you very much for watching the video to the end. God bless you. Enjoy the rest of the day. Bye.